Hey guys, welcome to this next Python tutorial. Today we're going to have a look at association relationships, so aggregation and composition. I'm going to assume that you know about UML diagrams from the lectures, but first I'll quickly outline what these relationships are, and then we'll dive into how we can implement them in Python. So an association relationship between two classes, class A and class B, is a has-a relationship. For example, a car has an engine and a car has a wheel, or a person has an arm, a head, or a leg. This is usually represented when I have two classes, class A and class B, and class A contains an object of type class B as one of its attributes, or when instances of B are constructed inside A. So in UML diagrams, we represent this association with a diamond arrow, and the diamond goes on the side of the container. So in this case, the container is A. In aggregation, we use an open diamond, and in composition, we use a closed diamond. Now, what's the difference between aggregation and composition? So the main difference is that composition implies that the contained class cannot exist independently of the container. So think of a page. It can't exist without a book, since the book is composed of pages. If the container is destroyed, the child is also destroyed. While with an association, the child can exist independently of the parent. So think of a car and an engine. The engine doesn't need to be destroyed when the car is destroyed. Okay, let's look at some Python code for this car and engine and book and page example to see what the differences of aggregation and composition are when it comes to the code. Okay, so here I have some code for the car and engine example on the left and the book and pages example on the right. So recall that a car and engine is an aggregation relationship, meaning that when we destroy the car, the engine can still exist, and that book and page is a composition relationship, where when we destroy the book, all of the pages are also destroyed. So let's have a quick read through of the code. So on the left, we have a class car and a class engine. In the constructor for the class car, we take in an engine and a make, and then set these as the private attributes, and we also have one method to drive. On the right-hand side, here we have a class book and a class page. In the constructor for book, we don't accept any arguments. However, we construct an array called self.pages, which is a list of pages. So in the constructor, we're creating 3 pages using the page constructor. And then our class page simply has a constructor that accepts the page text. And then we have a string method so that we're able to print out a page. Great, so as we mentioned, an association relationship is a has-a relationship. So taking a look at the car, we have an attribute called self.engine, and the type of this attribute is an object of type engine. So as you can see, this is a has-a relationship where a car has an engine. Book is very similar, such that it has an attribute called self.pages, where the type of this attribute is a list of page objects. However, taking a look at the main function at the bottom of each of these programs, here on the left-hand side, as you can see, we're creating an engine, and then we're creating a car passing the engine that we created into the constructor. So the car class accepts an engine object in the constructor. However, in the book class, we're simply creating a book, and the pages are being constructed inside the book class. So with the car and engine, say I was to delete the car that I created. So what I'm going to do is just comment out my car. We've deleted the instance for car, but the engine still exists, since this is an aggregation relationship, not a composition. However, looking at the book and page example, say I wanted to delete the book, so I'll comment out the line that initializes the book. Notice that the pages now no longer exist in memory. Since the pages were constructed in the constructor for book, once the book is deleted, the pages are also deleted. So when it comes to telling the difference between aggregation and composition, have a think. If the container is destroyed, does the child element still exist? If it does, then it's aggregation, and if not, then it's composition. So that's how the different kinds of relationships are modeled in Python, and that's all for this video. Thanks for listening, hope you learned something.